Hey again, and welcome back. Today I wanted to take a look at this thing. And what this is, I don't know if you can read that. This is a Honda part. This is actually I think it's a turn signal out of a side view mirror. It's pretty cool. A lot of my coworkers, when they find cool stuff, they just hand it over and see if I want to make a video out of it. And, well, here it is. So I don't think this will be too complicated. If you look, it says here 12 volts and half a watt, and only has two connections. But I think the interesting part of this is there's a light pipe. I can probably just see the LED right there, and there's a light pipe coming all the way up here. So I'm going to pull in the power supply here, and we will see if we can get this to light. I have it set to, I have to block both sides now, 12.36 volts. I have a current limit on it just in case I short the leads together. But let's see if we can get this lit, and if we can, then if we can pull it apart and see what's going on the inside. I don't think the clips are touching each other. Turning it on. Oh, there we go. So you see it's lit, and you see here there's like lines, and it's projected forward no matter how you turn this. You can see the light here, and it just follows with this turning, and it's the brightest at the very tip here. So it's pretty interesting. Nice kind of orangey, ambery type of light. So this is going to be a destructive teardown, because I don't know if you can see here, but it looks like it's a seal all the way around. So this is going to break, but you know, science. The only thing I don't want to break is the light pipe. So this plastic's okay to break, but I don't want to break the inner cool part. We're going to take a look at that. The thing with automotive parts is I know like the thought is that they're made extremely cheaply, and so they break really easy, but really the failures you see are not the norm, unless it's a known issue. Oh, almost stabbed myself there. Yeah, automotive parts are built to pretty high standard. And yeah, you're gonna say, not this company, not this company, this one or the other. But in truth, if you figure the amount of stress you put on automotive components just by driving your car, just by having it in an environment where the weather never cooperates, nothing ever stays still. It's quite impressive. Now this is breaking into a million pieces. I'm going to be finding shards of plastic all over for a long time to come. But it's all worth it to get in here. The seal on this is really good. Very sturdy. There's the light pipe in there. I want to be careful not to damage that. There's a little bit of circuitry here, but not much. Okay, well, I managed to spray shards of plastic all over my streaming room, or my recording room, I should say. But I did get the two components out, so let me clean up a little bit and we'll take a look at them a little bit closer up. Okay, so that was a mess, but I did get it apart. So here are the light pipes. You can see here there are two little pips, and those pips go on these two LEDs. We have the two pins here coming from the harness, and it looks like there's a bunch of resistors in parallel here. They are 6 to 1. Oh, looks like 6 to 1 and 8 to 1. Okay, hold on a second here. 1, 2, there's 3 6-2-1s and 2 8-2-1s, and they're all in parallel. 6-2-1 would be 620, and 8-2-1 would be 820. So I guess they're doing that to get the resistance exactly where they need it to be. It looks like I'm not sure which one here is the positive, but if you look at it logically, so it comes in here through a capacitor to an LED, through another capacitor, across these leads here, and then through an LED, through another resistor at the end here. Resistor is 270, so either 270 or 27, not sure. And it looks like there's a diode here. So it looks like it comes in, goes through two sets of capacitors, through this LED, through the diode, across this resistor, through the next LED, and then across these parallel resistors to the other side. So let's see the polarity here. So I'm just going to activate this. Nope, the other way. Yeah, okay, so positive is over here. So it comes in, and it looks like it goes right across through an LED, through that diode, through that resistor, through that LED, and across these parallel resistors, and then back out to negative. That's pretty simple. I mean, I don't know why they put the diode. It could be a Zener diode. If it's no, I don't think so. I wonder. They probably put this in case of reverse polarity. So if you reverse the polarity, it's not the LEDs that have to stop the flow. It'll be this diode. They did put a bunch of parallel resistors here, and the light pipe is interesting. So the light pipe, it's just a smooth piece of clear plastic, and you'll see there's notches here, and these notches will actually let light out at those positions. So if I light this 1 and 2, nope, the other way. Okay, so these are lit. See if I can line this up. They do have little cutouts where they go. You can see how powerful the color is, or the light coming out of the tip, but you can also see on those notches, see, the light is coming out of those notches. So it's just a cool effect that they can do with, basically this is fiber optics. But yeah, I just thought we'd take a close look at this. It's not every day you get to pull them apart, but really, if you think that your builders are spending a lot of money making turn signals and whatever, just know that, yeah, there was a bunch of design work that went into this, but to actually manufacture this board probably cost them pennies. A lot of the accessories you see on cars seem really expensive, like screens and whatever, but actually they're pretty cheap to implement. So some models have these turn signals in the mirrors, and some models don't. And they use that to differentiate between the cheaper and the more expensive models sometimes. But now you can see that the more expensive model sure had more design time, but really, hardware-wise, there isn't much involved. So once again, thanks for watching.